Today we have case studies. In the first instance, some case studies will be taken for repair and rehabilitation by Shri Jaygopal ji. And then very important topic based on the case studies will be taken up by Shri A.K. Srivastava, former ADG. And those case studies will open your eyes how a bridge can fall and what are the basic reasons, what precautions we must have on those things. So I think these are very, very educative presentations, and you will enjoy it. Thank you. So I'll request Shri Jaygopal ji to take over the mic. Thank you.
Good morning to my fellow engineers here on the second day of the workshop on the bridges. Yesterday we dealt more on the technicalities, instruments, testing, their results, availability, manufacturers, and the composition of the structural aspect in the bridges. Now let us get into the advanced mode of what we presented today. The advanced mode will be hands-on experience. Probably you must not be having this advanced method of working here, because this hands-on experience, whatever gained at various places in the country and abroad, will certainly put our thinking and our technical knowledge to higher levels. In fact, majority of things are not at all taught in our colleges or not the books. Now, yesterday what you have seen there in the non-destructive or whatever testing, I don't think it is there except in few colleges that they called me and asked whether we will introduce these rehabilitation NDT techniques. Hardly here and there it is there, but however, in general, these techniques, either the non-destructive or semi-destructive, they are not there much. And using those equipment, using those whatever results you get from the field, how to correct your equipment, the structures is also not taught, and it purely comes on the experience basis, and that you can gain from your seniors, bit more seniors and very, very seniors. That's the reason in civil engineering, probably I don't know how many of you know that in civil engineering you must always respect your next senior engineer, because what you can learn from the field in about 5 to 10 years, your senior will teach you in hardly a week. We always respected, and we have been brought out in that sense, and that way only here. And coming to this one case study, an interesting case study which was done very recently, condition assessment for repair and retrofitting of Bhagat Jatin Road over Bridge, Calcutta. My request to you is, yesterday hardly we got any questions from the audience here. Today at least I expect in the midway also you can ask any question, because normally we keep the question hour last. Since questions are not at all coming from the audience, we request at least in the midway also at least you ask. There is no problem. Whatever we know we will tell you. Normally you must understand that in any of the workshops, any of these events, the question hour is fixed for about 10 to 15 minutes at the end of every lecture. Now, going to this condition assessment for repair and retrofitting of a flyover in Calcutta. It is a 4-lane divided, two separate structures in Calcutta. It's about 4 girder system and pile foundations, pile cap and piers, not plate piers, not other piers. It is circular piers with a cap on the top. Here, what I have seen in this flyover, probably all of you are putting the strip seal expansion joints, and your consultant, if you are engaged, he will give you only strip seal because he doesn't know about other expansion joints. Strip seal expansion joint we have virtually removed from our system in my state, Karnataka, because it gives just like a railway bogie movement, and also in addition it jumps. It makes the cars or whatever vehicles to jump at least about 50 to 100 mm when it passes on the expansion joint. See here in this, many of the flyovers in the Calcutta, you can see slab seal expansion joints. Please note down slab, S-L-A-B, slab seal expansion joints, wherein you don't get that railway bogie movement at all. It moves very perfectly there, and no lifting up of vehicle happens there. It's also in this bridge also it is such a good thing has been introduced. This is an ROB overbridge over the railway lines. There are eastern flank and western flank, about half kilometer each approximately. Type of superstructure is RCC. Spans are quite smaller, about 18.5 meter. Year of construction, see here, eastern flank it is about 20 years old, one side. The other side, similar, it is a parallel one. It is not 2-lane, I think it is 3-lane. Each is 3-lane. Built about 10 years back. One is 20, say about 10 years back. Please note, keep this in mind. Carriageway width is about 11 meters, usual carriageway. 3-lane each for both west and eastern flanks. Presently, all categories of vehicles are being allowed on this, and it's a heavily trafficked flyover because the frequent train crossing there, and a lot of aggregates pass into the city from the outskirts here. And what we have observed while carrying out the investigation, when we start with the investigation, what we observed was the poor internal integrity. What is this poor internal integrity? You get this internal integrity when you test the structural member using ultrasonic pulse velocity testing machine. Then only poor internal integrity will come. What is internal integrity? Is whether it is a dense concrete or loose concrete. How much loose it is, how many honeycombs are there. So that it shows, that comes into the internal integrity, and you have a code for that. To classify, you have 516. You can classify whether it is a poor, better, excellent or whatever is there. It should be approximately more than about 3.5 km per second. The velocity should pass through the probes. Yesterday we have shown you 2 probes, steel probes, passing, the ultrasonics passing from one to the other. So that there you get this internal integrity. And cracks in the superstructure, which was also observed. Honeycombs in the tensile zone. It is a dangerous thing. Yeah. Honeycombs in the tensile zone, please note, the concrete has not gone in the tensile zone at all properly. Then how do you expect, see, in order to complete a movement, in a bending movement to complete, suppose we want to complete a bending movement, you need to balance the tension at the bottom, compression at the top. That's the way your beam functions. A bending moment of whatever they say, 500 ton meter or whatever ton meter, when it bends, tension is created, same tension get transferred to the top in the compression zone, and your bending moment will get completed in that sense. So to complete that, your tension should get transferred to the compression via the concrete. Whereas your concrete itself has got honeycombs, lower values, or no integrity there, how it will not transfer much of the thing there onto the top compression. Thereby the structural failure, on the way to structural failure, such structures will be ready. Then the details about the structural members are the main girders, cross girders, end diaphragms are all RCC. Entire structural superstructure is RCC. And what we have done was all the details like sizes were taken, and examination of bearings was done, checked the bearings, expansion joints were examined, examination of deflection in each main girder was taken, how much it is deflected already. The vehicles are passing, it is a live ROB. We taken the how much it is deflecting. Then the structural members, superstructure and substructure are investigated. What are the parameters they have been investigated for? What parameters? Simply look at that, no. What we have done is compressive strength. We have taken out the compressive strength by removing the cores from the superstructure. Internal integrity is same. Ultrasonic pulse velocities have been tested at regular intervals. And cover to the reinforcement. Yesterday I told you it is a profometer. We have kept the profometer, taken the what is the cover, because that plays an important role in the durability of the structure. So the cover to the reinforcement has been taken. Corrosion levels in the embedded reinforcement, very important. Yesterday what we have told you, absolutely this is coming almost similar. Corrosion levels by same, that electrochemical half cell potentiometer. Please remember, electrochemical half cell potentiometer, which will give you the electrical potentials in the negative millivolts, has been taken here. That is a very simple one. You connect one wire somewhere there, the other wire, other probe, you keep it on the top, you will get it from your that voltage. There is no need for you to open everywhere, no need at all. Somewhere you open in one reinforcement to complete the circuit. That's all. Afterwards, your machine, this equipment will show you in negative millivolts. If it is exceeding 300, be cautious. If it is 250, no problem, because at least 200, 250 corrosion will be there, because when you put the reinforcement on the ground, at least some reinforcement will get corroded or rusted out. So when you put the here, you can make out to about 300, 350. If it is more, 400, 500, you must be more cautious. Look at your book, look at your code, it clearly tells you, yes, if it is 300, it is this much. Code is also a bit conservative, it has shown 300 this much, 350 this much. Exceeding 350 is too much of corrosion. That doesn't mean to say that, it doesn't say 400 means how much, no. Exceeding 350, it is your headache, that's all. That is engineer in charge at site. This was the slogan earlier days we had, and those powers have been withdrawn by the latest all consultants from your pockets. They have removed it. The engineer in charge at site has been removed from all your things. Earlier when we were in the department, we enjoyed that power of engineer in charge that site, we can decide what we actually required at site for the structure. So in this 350 or 400, in fact, how much it will, you may ask me, how much of the corrosion levels you can get? You can get about 500, 600, I have seen 1000, 1200 negative millivolts. When we removed, it is fully corroded, expanded. It is not shown outside. Outside it is very good. Inside, it is so much corrosion inside, but it is showing out from the your equipment. It is 1000 or 1200. Then crack measurement and of course distress analysis. You are not supposed to get a cracks beyond certain size. That is already mentioned in your codes. Then as I said, in order to get those characteristics, again I have already told you, ultrasonic, rebound hammer, impact echo, core cutting, testing, cover meter, tensile test for reinforcing bars, and test on corrosion. Just now whatever I have mentioned, the same thing is here, that have been completed. In fact, some of the bars were also removed from the structural member about a meter length and sent for testing to check the tensile strength. Here, condition assessment or health condition assessment has been done for various elements, especially the girders, cross girders, diaphragms and bearings. We checked all the bearings. One more thing here, what we have done was measurement of dynamic parameters through accelerometer, fiber brake grating and sensors. One more, this is an additional thing normally not done. Normally 95% we don't do it, but special cases like this, dynamic parameters like accelerometers, that is to check the velocity and dynamic characteristics of the slab. The resonance characteristics will come to know about it. If the resonance of the vehicles passing and the natural frequency of this slab meets the same, then it is expected that there will be formation of a hole on the deck slab. Fatigue plus this will happen, and that is the latest thing is happening. Then we did that load test on ROB with LVDTs, strain gauges, and for the 3 spans. Temperature measurements for 3 spans completed. Temperature, yesterday we showed you whether there is some problem with the heat generation due to some collapse. Something is happening, that for a precautionary measure we took the measurement. And these were the things used there. You can see additional testing carried out, temperature. These are all beyond our contractual obligations. Right side you see the GPR in action, ground penetrating radar. That will give you any delaminations in the slab. There is some delamination, that is your 200 mm slab thickness, 220 mm slab thickness, if it has got horizontal delaminations or vertical somewhere, this right side, your right side photograph, that equipment will show you all that. And the left one is the temperature measurement. These are the load test spans we have selected, and for the load test. That old structure that was built about 20 years back, 18 years it was shown there, 20 years back. Tested piers are these piers, P4 to P23. Integrity quality grading, ultrasonic pulse wave test, all piers except 10, 11, 12, 13 have been done. Core compressive strength obtained. Please note here, these are the results what we obtained from the site after taken with the sampling, either the ultrasonic or the cores. Core compressive strength is only 18.75 Newton per square mm. That is 18.75 MPa. Corrosion levels, negative millivolts, I was telling you about 350, whereas here 540 millivolts. Please note one more point, extremely important point. The pH value of about 10 samples or 20 samples what we have taken from the structure, the least possible was 7.16 was the pH value of concrete. Unacceptable at all. I have not seen such a low pH. Yesterday, that's the reason I was telling you how the pH values are. Yeah, absolutely 20-year-old gentleman has come down to such a 7.16. You can't expect the life of the structure with such a low pH values. pH of concrete is straight away related to its durability. Let it be anywhere in the world. pH is more, your life is more. pH is less, forget that life, it will come down. Or by any means, if you want to increase, you can increase to get back its life. It is losing it is becoming older and older. The chloride content is about 394 ppm, by and large okay, because chloride content is related to the quantum of cement what you put into the concrete. Sulfates also similar, quite lower sulfate because our code allows bigger high quantities. Cover to the concrete is very good, 76 mm. More cover also is not good because you get cracks at the bottom very easily. If it's about 40-50 mm, it's okay, manageable. Then again some more details of almost similar nature in some more places. 21 instead of 18, now you got the 21 here, same structure, either this or that. The pH value is about 7.28, earlier the 7 point something was there. Chloride content here 415, manageable, okay, it is just in the so-so. The cover is very good, extremely good. Sulfates also very good. Then we have checked the girders. These girders were poor, doubtful in 5 spans, mixed results in 3 spans, excellent results nil. There were no excellent results. And see, one of the girders, core along with the crack, when we removed the core, this is the type of core we got. You see the center crack there? Again, the tested girders, these are superstructure. I think earlier I showed you the substructure there. Here, superstructure, again, the core compressive strengths are on the lower side, it is less than 18. Corrosion levels 340, slightly higher, not acceptable. pH value gone case, it is absolutely miserable, it is with 7.13. Please note down, when you make it, don't say carbonation, it is happened carbonation. Carbonation can happen from 11 to 7, anything can happen. But if you say 7.13, then people will understand, yes, this has got a problem with that. Then chloride content is about 412, so margin, sulfates okay, cover is, it's by and large okay. Then old structure also, internal integrity, poor and doubtful in all the spans. Poor and doubtful in all the spans. There is no, unlike a good, better or at least marginal, nothing like that. Then old structure, tested deck slabs, again girder finished, we went to the deck slab. Again deck slab, core compressive strength about 17.5, corrosion levels 390, it is quite higher. pH 7.98, it is below 8 only, not acceptable. Chlorides, sulfates, cover, they are all okay in this range only. That's exactly the reason yesterday I told you, when you want to rehabilitate a structure, please take out a core, you don't do anything first. Whether it is fit enough to do the rehabilitation, investigation also you can make out. You just take out a core, cut it, set it to pH value, if it is quite less, no need to do anything further. No need to put your stethoscope there. You can simply say that put a new estimates, replace that. Only superstructure. Then the new structure, piers, again piers, the circular piers what you have seen there in the first photograph. Piers, again almost similar results are there, 18, corrosion levels are very high, 400. pH is again low, only 7.98. How do you make out the pH? 7.9, 8.9, 10.9, how do you make out? It is not a big thing. You get a pH meter in the market. You crush the sample, put in water, take the sensor and dip it inside. Immediately you will get the pH value. You can do it in your, suppose you have a regional laboratory in your Raipur, you can do it there only, buy an equipment. I don't think that should cost beyond 2000, beyond a lakh rupees. A good one. Many types of equipments are available in the country. You can make it out. There are strips for emergency. You can take the strip pH value. Strips are available. Paper strips. You dip it. Emergency. That is, go to site and just dip it and check it out. Phenolphthalein solution is always there, but that gives you only carbonation. Please see this. Quite disturbing results. Then the caps, pier cap, again almost similar, almost pier is same, almost pier cap is same. Then you go to the girders, again similar, mixed results 5, doubtful results 1, good and excellent results 1. Then again the strength characteristics almost same. In fact we started from the old structure, that is substructure, pier cap, deck, below that depth girders. Similarly we are coming like that only in the new structure also. In the deck slab, these are again the doubtful mixed results. Excellent, good, very good is not seen at all there. Deck slab again same, 7. Corrosion levels are bit under control. I think 195 negative millivolts is there. There is no much of the corrosion problem here. pH is again down. Cover is not there, only 25 mm. And with these type of results, you can ask me, yes, your investigation is correct. What you did with that? We completed the results. We said that your deck slab, girders, pier cap, piers are unfit to be under service. Gaadi ja raha hai, vehicles are going, everything is okay. It has completed the load test also. The load test is completed satisfactorily, but chemical composition what is required, it is not there in the structure. For durability consideration, it is unfit. And since the pH levels are so high, so low, and the corrosion levels are so high, compressive strengths are hardly anything. When we checked out, of course, it is taking the load. Even with 10 to 12 Newton per square mm also it is taking the load, because we checked the cross, verified the designs also. It is taking, there is no problem. But durability wise, we just do not know when it will crumble up. So additional strengthening measures were given by putting some additional strengthening at the mid spans and some cross beams, cross girders, so that only for the safety sake it has been taken care. When we combine, see here, what you see here, compressive strength you can see, corrosion levels you can see, pH value you can see. You will have to integrate all this into one unit and check what is the effect of compressive strength on all other parameters, what is the corrosion levels on all other parameters, what is the pH value, what is the problem with the pH value on all other parameters. You will have to separately see, combine. It is like a sambar. What you make some different, adding so many things, getting the good results at the end. That's the way you should do it here. and you should do it in a very justifiable manner, so that your structure, whatever relevantly required there, only you will take into consideration. You need a slightly experience. You keep doing that, you will get it. And this is my experience as far as the case study of one of the structure recently done. And if you understood, kindly ask me even the fundamental. If you are not understood also, you can say, tell me I are not understood. Any questions? Yeah, please.
So core cutting का लेंथ कितना लेते हैं, कितने डेप्थ तक core cutting करते हैं?
Core cutting, yeah. See, actually core cutting is not much depth is not required. Core cutting you will have to do only 2D. 2D. Suppose, see, I will also tell you one more thing. Sometimes you encounter a reinforcement, you will not be able to take depth properly. Your depth H should be more than your D. Diameter, please don't take course of 100 mm, 90 or 100, don't do it. 70 to 80 mm is more than sufficient when we go as per the code, 70 to 80 mm. And you get the core cutting course of that diameter very easily in the market. Go there, core cutting, if it is about 75 means you go take about 150. If it is less than H, suppose you less than H, then go to Neville. How many of you people know the book of Neville, Concrete Technology by Neville? Fantastic. Any other fantastics? Only one. Please purchase, give money, purchase a Neville book from the market, or go to Amazon and buy it out. Neville, N-I-V-E-L-L-E, I think so. He is a British English writer who has written a fantastic book. It is relevant even today. Just read that, more than sufficient. Daily you will read, you get all the things. What I told you for the core cutting, if you don't get, code doesn't give you. Our IRCSP, IES 516 will not give you what is the size and all. Size, it says one thing. It should be between 1D and 2D only the depth. For and correction factor apply, get the compressive strength. If it is less than 1D, it doesn't tell you anything. It says clearly 1D and 2D. But if you reinforcement आएगा तो क्या करने का? That time, open your Neville book. That will guide you exactly how to do it.
आपको इस स्लाइड में जो 2D से ज़्यादा दिख रहा था, कोर का जो लेंथ है,
कौन सी?
स्लाइड में जो दिखा रहे थे कोर कटिंग, वो 2D लेंथ से ज़्यादा दिख रहा था.
No, that was an investigation. That's not for compressive strength. Compressive strength separate ले लिया. Because what we saw was a crack. We wanted to check how much the depth of crack is there. And that there we have shown you. Yeah, this one we were talking, I think. Yeah. See here, length of the crack is there too, totally. Oh, this LED, that line is, you are not able to see, I think, there. Here, along this, full length crack is there. Full length, and we wanted to find out what is the length of the crack, what is the depth it has gone. It is whether it is pura hai, aadha hai, so that at least we can come to know about it. That's the reason we went for.
सर ये जो रिबार डिटेक्टर मशीन होता है, रिबार डिटेक्टर मशीन जो है, उससे कितना डेप्थ तक अपने को रिबार्स दिखते हैं? रिबार
डिटेक्टर, any of the good rebar detectors you can measure up to about 100 mm, 100, 120, not beyond that. If it is less, like 50, 60 mm, you can find out the diameter also. Diameter also you can make out, and the cover thickness also you can make out. If it ज़्यादा है तो, cover ज़्यादा है तो, इसका efficiency कम हो जाता है. When it becomes lesser efficient, then you don't get such results. First you make a trial here and there, get acquainted yourself. Yes, it is possible, we can do this.
इन्वेस्टिगेशन में जो क्रैक इन्वेस्टिगेशन में जो कोर था, लंबा कोर था, तो ये रिबार डिटेक्टर से तो डिटेक्ट नहीं हो पाएगा रिइंफोर्समेंट, और रिइंफोर्समेंट भी कट हो जाएगा उसमें।
See, reinforcement you should not cut it. A rebar detector is there only to see that you identify exactly the location of the reinforcement and you don't cut that reinforcement. And we should not disturb the reinforcement there.
अप टू 120 mm तो डिटेक्ट हो जाएगा रिइंफोर्समेंट, उसके अंदर
इसके अंदर का आप गए तो it will give you noise. It will give you a noise and you cannot cut so easily. Concrete है तो सीधा चला जाता है. And if you encounter steel, immediately you will get the noise. You cannot cut also so easily. So you should know that there is some problem there and stop that. And we should not cut any reinforcement inside unless until the steel is required for investigation. Like in this case, it was required. We removed a steel bars, about 4 or 5 bars. We removed it by chipping and removing, cutting, and sending it to the laboratory for tensile testing. But in fact, as consultant, we told no, we will not do it. But owners told no, you take it out and test it. We need a full confirmation. So that's the reason we took out reinforcement ले लिया, बाद में उसको भी test कर दिया उसको. But that is not admissible. Because in the load test you can make out, when you do a load test, you can make out backward calculation. You can make backward how much bending moment, how much it is taking load, how much you can put the loads, what vehicle you can put SV loading 70 or 40 or whatever, you can backwards work out backwards. So in that case, why do we unnecessarily remove the steel and unnecessarily it's not required? Investigation doesn't mean to say that strip off everything and look at it. No need. Sir. Please, sir.
हाँ ओके। अच्छा, आपने पूछा है ना कि कोर कटिंग का पूछा है, अच्छा सवाल पूछा है। देखिए इसमें कोर कटिंग में जहाँ तक मुझे एक्सपीरियंस है कि कोर कटिंग उसी टाइम में करते हैं जब हम यूपीवी अल्ट्रासोनिक पल्स वेलोसिटी से और रिबाउंड हैमर से जिस एरिया में चेक करते हैं और वहाँ पर सस्पेक्ट एरिया डिफाइन होता है। अगर वहाँ पर सस्पेक्ट एरिया है तभी हम कोर कटिंग में जाएंगे, नंबर 1। नंबर 2, जैसा साहब ने बोला कि कोर कटिंग जब करते हैं तो रेनफोर्समेंट अवॉइड होना चाहिए, नहीं आना चाहिए। कारण कि जब अगर आ भी सकता है, जैसे पतला बार हो, अगर 8 mm है, आप सोचते हैं कि 8 mm कट गया, वो कोर के लेंथ में आ गया, कोई बात नहीं। लेकिन जब वो टेस्ट होगा कंप्रेसिव, जब मशीन में डालेंगे तो उसका इरोनियस रिजल्ट आएगा। तो इसीलिए जब कोर कटिंग करते हैं तो उसके बीच में किसी फॉरेन एलिमेंट्स एक्सेप्ट कंक्रीट शुड नॉट बी देयर, नंबर 1। नंबर 2, जब हम कोर कटिंग करते हैं तो इतना आप चिंता नहीं कीजिए कि हमको 2D ही निकालना है। अगर हो सकता है कि ज़्यादा भी आएगा कम भी आएगा, उसका क्या होता है कि डायमीटर के अनुसार, अगर ये भी मैं चिंता कीजिए कि हमको 100 mm से कम आ रहा है तो दिक्कत आएगी, 80 mm वगैरह जो भी है, वो फिर करेक्शन फैक्टर लगते हैं। जब वहाँ पर मशीन में टेस्ट होता है तो डायमीटर और लेंथ के अनुसार क्या हमको और एडिशनल फैक्टर लेना है। जैसे रिबाउंड हैमर में भी जैसे ईपीवी में करेक्शन फैक्टर लगता है। जैसे आप डायरेक्ट लेते हैं, इनडायरेक्ट लेते हैं, तो डायरेक्ट में करेक्शन फैक्टर नहीं लगता है। जैसे स्लैब में एक के ऊपर एक रख दिया तो वेव जाता है और कैप्चर कर लेता है। बट ऊपर वियरिंग कोट है तो इनडायरेक्ट लेंगे तो वेव ऐसे जा कर के ऐसे आता है, ठीक है। तो इसमें करेक्शन फैक्टर देते हैं। उसी प्रकार जो आपका कोर कटिंग है उसमें करेक्शन फैक्टर डायमीटर का लगता है। क्रैक्स कहीं भी नहीं होना चाहिए, इसीलिए सैंपल निकाल करके पैकिंग करना ये भी एक बहुत बड़ा इंपॉर्टेंट चीज़ है। उसको ट्रांसपोर्ट करके कहीं पर भेजना, क्योंकि वहीं पर टेस्ट नहीं होगा, वो जाएगा लेबोरेटरी में। हो सकता है कहीं आपको भोपाल भेजना पड़े, हो सकता है कि बेंगलोर भेजना पड़े, हो सकता है दिल्ली। तो वो उसको वो निकाल करके पैकिंग का भी मेथोडोलॉजी है, उसको रखना और उसके बाद सूटेबल करेक्शन दे करके तो वो रिजल्ट इंटरप्रेट होता है। जो आपको जैसे साहब ने बोला 516 वगैरह में वो मेथोडोलॉजी है कि कैसे करेक्शन करेंगे, क्या करेंगे, क्योंकि हमको ओडल प्रोविजन के अनुसार भी चलना है। ये सब चीज़ें जो है, ये सब प्रॉब्लम्स को वहाँ पर सारा चीज़ एड्रेस किया हुआ है, इसीलिए इतना ज़्यादा चिंता की बात नहीं है। और जब भी कोड कटिंग करें तो आप एक एनफोर्समेंट से कवर मीटर से जरूर चेक कर ले कि कहाँ पर हमको काटने से एनफोर्समेंट का मेस नहीं मिलेगा। तो दैट विल बी वेरी गुड ट्रायल एंड एरर, सो दैट यू कैन हिट अपॉन एंड गेट द कोड। अदरवाइज अगर ऐसे ट्रायल एंड एरर लेना तो हो सकता है 4 बार करने पर 5-6 बार में मिले, एंड यू विल बी डैमेजिंग दैट एरिया व्हाइल कटिंग द कोड। So this is my submission. Thank you, sir.
Yes, sir.
One clarification for myself as well for all the other, attendees. pH value when drops below 9, it means corrosion has started and progressing.
Yeah.
When pH value has already dropped to 7 or like that, that means corrosion is almost setting.
Yes.
Right?
Yes.
But you said कि you proposed for jacketing and strengthening and allowing the structure for further use. Have you assessed the remaining life of the structure? How long it will stay? Even if you do the jacket, corrosion is not going to stop. It will continue and it will keep on deteriorating the strength of the structure. And although it is capable to take the load test, but say in a year or so, it may give up.
Yeah.
So how we can make an assessment
Yes, sir.
of the remaining life of the structure, so that we are, whatever we are doing, at least we can get the use of that. Scale of economies is available.
Sir, it's a right question. How whether remaining life has been worked out based on the so many factors which are going negative to the structure. Sir, what we have done is, it is the first time, I think in the first time in the country or first time in the entire part of the globe, what we have done, we have seen the structure in two different ways. One is the analysis, what you have seen there. One is the chemical analysis, physical, whatever analysis, what we have done. We have just seen that. In the other part, what we have seen is the load test. And what is happening here is, when we did the load test, it is passing and it is taking all the loads, whatever exactly our ARC SP 51 says, this deflection, itna hona chahiye, well within limits. Physically, it is taking loads. Whereas when it comes here, it is not at all in the limits of whatever. So what we did was, which is first? We should know that whether this all chemical analysis is first or the load test is first. Based on that only, in fact, I have written that one of the international IABSC, Turkey also, I wrote an article, it was presented there. Then which one to take first? Either this one or this one. So I told there, and in fact even IRC document also, one of the articles I wrote, we will have to take into consideration this chemical analysis into consideration first. If it fails, there is no need to go for this. And your first question regarding the what is the remaining life? We told hardly it will be about 1 or 2 years. Please don't. But when it will go into collapse or when it will go into the brittle nature, we do not know, because such things have never happened. Now, we should get an experience. Nobody has written any books. We don't have research documents. If anything happens, anything looking at this, such things will be into the record. Maybe after 4, 5 years, 10 years, then we will come to know kitna din tak lahega. But what we suggested was about a year or 2, try to go for strengthening, or our suggestion was not to go for strengthening, just replace of this one. Because, sir, there are pH value reduction or the corrosion levels. There are equipments available in the world. It is available in US, Europe. You can reduce the corrosion levels. If your corrosion levels are about 500, 600, you can bring it down. There you can put some electricity, some equipments are there. Very, very expensive. You can put 10 bridges instead of that. And pH values, also there are equipments. Depassivation, equipments are there, but that is not for these cases. The recommendation was to replace the top portion, and in fact we were surprised to ourselves only. We are able to separate out the capacity of the physical capacity of the bridge with that of its durability. And when I discussed with our senior engineers, other fellow engineers, they said that a fantastic thing you have done. How did you separate it out? Yes, it is better for our engineering fraternity. Which one to take first, this or this? If the durability is there required, this you should take. Suppose if you take physical, if it collapses, what you will do? So first preference is the chemical analysis. That's the reason I told, वो core cut निकाल के वो करके, then go to the pH, check it out, then you think over उसको क्या करना है, then yes, decide, rehabilitation करना है, jacketing करना है, then carbon lamination करना है, all those things you can work it on.
Finally, your decision is to go for new construction.
Yeah. In this case, new construction superstructure. See, pile cap was good. Piles were good. In fact, we checked the piles also.
Piles are good.
Pile cap was also good. Pile cap है वो there are circular pier like circular piers actually 4 numbers.
What is your final decision
To go for a reconstruction. Yeah. But we can't do reconstruction instantly. In about 2 years, we told in 2 years or whatever possible. Both. I was surprised how new structure also reduced its pH value so much. That's the reason when we did about 3-4 years back, we were just thinking that what has gone wrong? Why it is so much? Within 10 years or 20 years. Sir, I will tell you 1950, that is about 70 years old bridges and aqueducts in Karnataka. I have seen, especially in your 17, sir, NH 17, pH has not gone down below 11. pH of the bridges, that too in the ocean side, at the adjacent, hardly half kilometer, 1 kilometer, 11, it has not dropped down to 11. Below 11, it has not gone. That means it is not corroded. Steel is not corroded. Many of the places steel is not corroded. Not many, 95%.
What is the reason for this pH?
Going down pH value, sir.
It is cement. What type of cement is it?
Sir, we are going through that, and if the day I crack this, and definitely I know that Nobel Prize is waiting for me. I do not know, but what we found out, because we went backwards and found out that this wet method of manufacture of cement and dry method of manufacture of cement is the main cause. That chemical analysis, if we are through with that, we will publish that in the paper. Sir, such questions at least make us to think more, and our thinking also 1% increases.
नोबेल प्राइज की जगह पे सारे सीमेंट मैन्युफैक्चरर भी पीछे पड़ सकते हैं.
पीछे पड़ सकते हैं.
अच्छा, one more thing.
Yes, sir.
I mean, having known the corrosion has set in and pH has gone down, why did you think cathodic protection measures can be implied so that corrosion can be, arrested, and after you strengthen it, it can last for longer, because load test has already shown that it is functioning very well. And another thing which you can, we could have suggested, that let us, keep on observing the structure for serviceability limit conditions. Any cracks, further cracks, or any, sagging or any whatever it is. And whenever there is any sign of it, then we should discard this bridge and stop the traffic.
Yeah. It is basically it is under observation.
Right.
And because that was a contract, and senior engineers are there in the Calcutta, and normally they keep reporting, even though they didn't tell us, but they keep telling us, yes, something is going wrong here, or you come and have a look at it. That coordination is there.
Any idea what kind of instrumentation we can put in, some strain gauges or something?
No, as you told, henceforth in our structures we must keep
Yes,
instrumentation के लिए separate estimate में डाल दिया तो
At least any bridges more than 200 meters must have health monitoring system.
Health monitoring system.
Yeah. Yes.
एक्सक्यूज मी सर बिफोर कंस्ट्रक्शन हम सीमेंट का पीएच टेस्ट कर लें तो सीमेंट का ही टेस्ट कर लें पीएच
Cement?
हाँ इनिशियल कंस्ट्रक्शन से पहले
Yeah.
हम सीमेंट का पीएच टेस्ट कर लें और एग्रीगेट का कर लें
Yeah. If you test this cement, you will get pH value between 13.5 and 14. Any cement you take, वो PPC का तो थोड़ा half कम आता है. OPC definitely will get around 13.75, 9, 14. There is no use in doing that because in this case, both the cases, it is same. When you mix it, you don't get anything. When you mix it, when you actually do the concreting, you don't get anything. But when after years, several years, maybe 50 years, 40 years, then it will start showing. Because the western, our state, we have a west coast highway, NH17, starting from the bottom Kerala, it is going up to the Mumbai. Those roads, I still remember some of our senior most people, they constructed there somewhere around 1960s, 65, 70s. Those days they must have used that cement. How come it has not come down below 11? We checked it, that's the reason. And that aqueduct, sir, yesterday I was speaking about that aqueduct. I think it is about 1953 built. Absolutely in pitch good condition. 53. We should say hats off to our senior engineers. Those days I think he was also looking after Dr. Saramisha Shaya was also in charge of certain irrigation projects. In fact, I belong to the same district where he was born, Kolar district. And those days they were all quite, don't say strict, they were doing the job perfectly. And you know what, I have the photographs. They were mixing with a small mixer, concrete. Even today, after 70 years, the aqueduct doesn't leak even one drop of water. Steel kept, concrete mix, all kache, this our bold laborers, and tripods, wooden tripods, and with a small pulley, we use it for taking out water from the wells, and small well foundations, 8 feet diameter well foundations. Out of that, 4 feet is the diameter inside. They used to go inside, then take out the sand and sink the wells. Like that, I think they have done about 300 or 400 wells. Alignment perfect, level perfect. With so much knowledge also, we don't do that nowadays. We just say, okay, chalta hai. Cement, you don't get results now like that. 13.75, 14 you will get, irrespective of whatever type of cement. But you should see that after 50 years, how much pH has gone down. Yes, sir.
सर कंक्रीट का पीएच वैल्यू कितना रहता है सर? कंक्रीट का पीएच वैल्यू कितना रहता है?
कितना रहना है? When you take out a core, you slice it, you make powder, you check it. You must.
At the time of pouring concrete.
At the time of pouring, you will get, you will want it, you don't want also, you will get more than 13.5. Because that is a raw cement. Cement is lime. Lime is 14. Because when we understand the chemical nature, this is acid, neutral, alkaline. Acid from 0 to 7, 7 to 14 is alkaline. And you will certainly get, that is because it is lime, you will get certainly. Acids all will be coming under that 0, 1, 2, 3. Hope the questions are limited.
Sir, excuse me. Sir, if we go for post-monsoon or pre-monsoon investigation of a structure, and we find bending moment cracks at the bottom and shear force cracks in the faces of structure, what are the immediate remedies we should perform or we can perform at that point of time so as to maintain the serviceability of bridge for some more period of time? Is there any remedies?
Suppose you find any bending moment failures or reduction in failures, immediate measures. I I think Pandey Saab yesterday has given you some things, pre-monsoon and post-monsoon. They, in fact, Ministry of Road Transport Highways, Saab to dono Saab hai, they are the masters and experts from the top. In fact, they should be able to tell. But what we do is pre-monsoon, post-monsoon. Suppose you find some problem, temporarily put some support and leave it for the rains to pass off. Afterwards, you take any measure, like see, there are various rehabilitation measures. You can go for the encasement, put the additional reinforcement, or carbon fiber wrapping, or lamination. You do whatever you want on that basis, and put a load test. Basically, check it out whether it is taking the loads or not. Many times, what happens is there are shear cracks, there are flexure cracks. Many times there are both the cracks. There are shear as well as this one, flexure. Go for a load test. Go for, mercilessly you go for a load test, nothing will collapse. Because hardly one beam or the other beam will have a crack. And failure occurs when this and this all put together only, then only failure occurs. So, and that too you are doing the load test 51, as per 51, progressively. You are not putting the full load. You are putting the loads very slowly, like 30%, 50%, 90, then 100%. Something like that. 53, IRCSP 51 is the code. That code clearly tells you progressively put it. You will come to know at what exactly deflections are going more. Theoretical calculations you can make out. You just calculate the theoretical calculations. The deflection allowed at this point is about, say about 10 mm. So don't allow deflection to go beyond 10 mm. To that 10 mm, what is the load you calculate? Then you restrict the load. Then you put up a board. The IRCSP 37 very clearly says you must rate the bridge. You must rate the bridge and put the boards exactly at the bridge site and about a kilometer on that side and this side. Put two boards, rate the bridge. If it cannot take 70 R, say clearly 40 R. Or 30 R, 20 R, whatever it comes, you put that. This bridge has been rated 20 R or 40 R. Beyond that, loads are not allowed. It is easy to do whatever. If some problem is there, you can put some police on the scene also. I will. With this, I have one more, last one is there, that is a small one. I will, again a case study, last one. Sometime about 1.5 years back, rehabilitation of Marvur Bridge across Gurupura River, Mangalore. Mangalore, it is just below Mangalore Airport. Airport is there on top, this river is below, it is adjacent to Mangalore city. And that Mangalore Airport is serving entire that side of Kerala, Karnataka and all from airport they pass through this bridge. They pass through this bridge, go to Mangalore, go to Kerala, go everywhere. And something went wrong with this bridge. They used to go all round for about, I think about 30 kilometers all round, make one round and come back. And things went wrong. It was not expected. It went wrong. Details of the bridge is about, bridge has 9 spans of 20 meters each. It is not very much. It is an RCC girder slab bridge with plate piers, pile cap RCC, piles for RCC, and it was built around, I think, 1960 or so, or 70. It was not a modern structure like our what you build well caps bigger, pile caps bigger. No, you can make out a small thinner 300 mm thick slab on the well cap. See, this is the well cap thickness, and wells are square here. Square wells, 2 numbers, I think built by somebody from Andhra Pradesh. And the problem was not there much because it is a sandy strata, they could easily sink these wells. We checked up, it's about 25 feet or so, about 8 to 9 meters in depth. See, this is what happened. what happened was about 300 or 400 mm one pier went inside river. It was very heavy monsoon, very heavy in Karnataka. So the cover has taken place adjacent to that. That has pushed down the pier. Now God's grace, it's only this much, and it didn't go more than this. See this crash barriers broke at the expansion joint place. Again cracked up at the abutment because it is lifted up. The other end is down, so this end is raised. That's the reason you get here crack at the abutment. Then what to do? Then immediately they called me actually. What to do with this? I had work. I said I cannot come. I got some other work. So the chief engineer and all others asked me immediately, sir, please come. We are also coming there. We try to sort it out. All traffic was closed. In fact, people also not crossing on that because they are afraid, because it is like this going down. So what to do? Then I went and checked up there, and further to arrest, I suggested you do one thing, you get some boulders. I know well, boulders, if you are doing it, it is very difficult afterwards. You cannot do any rehabilitation of your below piles of caps and all. That will be difficult. So I said, okay, presently let us sort it out. So we put the boulders so that further settlement of the wells or well cap doesn't occur because of friction created there. In fact, even I suggested some coconut trees, if you can cut and put it up there, that will impart lot of friction, because that has been taught to me by seniors about 40 years back when I was working in public works department. Even the ministry people also, they told, put some leaves, they say, leaf cut karke side mein dal dene ka, so that it will give lot of friction, so that it doesn't settle down immediately, quickly. So we put some boulders there, arrested, and whatever cap you see, we rebuilt that cap. Yeah, this cap, we rebuilt that cap with additional reinforcement. I don't know, I don't have photographs of this reinforcement and concrete. Then the pier also was encased, because while going down, it has not gone down vertically down. It has not gone 100% like this. It went down and it has slightly tilted also slightly on one side, about 100 mm and 200 mm, because the superstructure cannot sit properly there. Then while doing that, first what we did was we sandblasted the complete surface. After sandblasting, reinforcement anchors was put. I should have got all the photographs, that would have been very useful for you. Then we put the vertical reinforcement, then the stirrups, then we put I think about 150 or 200 mm encasement we did with micro concrete, M70 grade, specially made micro concrete. One of the manufacturer's factory was there nearby only, he supplied us. We did that, cap was put. Again, the entire pier was raised to the zero level, earlier whatever level was there. New pier cap was put, new pedestals were put, new bearings were put, and 2-3 spans new bearings were changed. Almost when you have a look at it, you cannot make out how much it has settled. Afterwards, this all was done, completed in about 45 days. And see here, we did that load test. We did that load test with this strain gauges you can see on the top. Strain gauges is there on top. Here. And we fixed also here FBG, fiber brag grating. Fiber brag grating is a new thing wherein In one wire you can put some 100 strain gauges, and you can fix all at different locations. You can get the strains at wherever you want in one machine. That is an excellent equipment. Even small wire you actually you cannot see. It is this much only. It is a cellular, like you cannot see. When you take a step, this one wider that glass, then check it out, then only you can make out. It is a so thin one, and that gives full-fledged strain measurement, much accurate than your regular electrical strain gauges. So that is there, and the girders were lifted up using hydraulic jacks. It was like this, bent down. Some temporary supports were put on both sides of the pier and lifted up and made level properly, and the pier was repaired. You can see here, repaired pier, repaired pedestal. This is by load testing, and this is a newly casted, encased pier, completed pier, ready for load testing. And this is load testing is in the midway progress. You can see there, this is as per IRC SP 51 designs were checked and all. See here, in fully loaded trucks, and the measurements were taken at the bottom. I was telling you to FBGS, fiber brag grating strain gauges, very, very important. This is available in Germany and Belgium. Quite costlier, but however that can be used to whatever our needs. And this is one of the photos where it is already span is completed and the pier is completed. And this is the thing, this was completed in about 45 days, and if at all we were to leave for about a day or two, while checking that, probably that would have collapsed, because one of the span was just sitting here. It is sitting maybe about 100 mm or 50 mm, it is at the edge. Any moment this breaks, then it will go down. Somehow we gave support in the beginning stage itself. It took about 45 days to complete and leave the traffic. In fact, there was a suggestion from the Public Works Department, our executive engineer, sir, thoda car chhod denge pehle, truck kyun deck afterwards, something go wrong. Then I said, no, 51, you have completed, the report is there, signed, chhod den. In front of me only, I told you, please allow bada trucks chhod denge. It worked well. And MLA was there to cut the tape, and he was happy. Public was very, very happy. As civil engineers, I am telling you, such occasions, just look at our faces of our general public, how happily they will be going. You will feel elevated on the top. So with this, I end my second presentation also. Here there is nothing questioning or anything, clarifications you can ask me maybe in the tea time, or any time you can ask me. That's all. Thank you very much.
Thank you, Jaygopal ji. Now we'll break for the tea.
Yes, sir.
Right. Thank you.